Hey guys, I'm Jack, one of the co-founders of Turnkey. I'm the CTO. So I was at Coinbase for a long time working on infra and security over there. That kind of led to working on Coinbase custody. So I was the first engineer working on Coinbase custody and kind of built out the cold storage system that sits underneath Coinbase custody and now actually all of Coinbase. So that was kind of intro into key management, crypto security stuff. Went over to Polychain then, did a ton of like long tail asset custody work over to Polychain, and that led me to build Turnkey. Okay, so what are we going to cover here? A little bit just around like the fundamentals of key management, things that are kind of involved in the process. Going to spend a bit of time talking about things that I think are overlooked trust assumptions in crypto and security considerations, and then basically like what is Turnkey and how are we doing things a little differently. Okay, so kind of basic. Everyone in this room probably knows these three things. Okay, there we go. Okay, so key management kind of comes down to three different sort of parts of the process. You have key generation, key storage, key access. Storage and access kind of go hand in hand in my book, and generation of keys is like oftentimes super overlooked in my mind. It's very easy to get wrong. It's very easy to shoot yourself in the foot when you're generating keys. It's very kind of opaque when you're using bad entropy is sort of the TLDR on that. We have a guy at Turnkey who his name's Lance. He works on a lot of our kind of like really low level build systems. But he was responsible for finding the CVE last summer that's called MilkSAD. Definitely check it out if you guys want to take a look at this vulnerability. MilkSAD is basically issue in the generation of keys from this tool called BX. So BX was kind of a very commonly used Swiss Army knife crypto tool that's included in the Mastering Bitcoin book. So it's kind of like all throughout Mastering Bitcoin, there's this like tool that's referenced and there's examples of using BX. The BX like seed generation was just completely broken. It basically would deterministically produce a crypto private seed based on the time that you actually executed the call, like the Unix timestamp. And so if you just knew exactly when someone had generated a key, it would just produce the exact same seed phrase every time. So yeah, the name MilkSAD actually comes from, if you plug in the Unix epoch into BX seed, you get a seed phrase that's like MilkSAD something. So anyways, a lot of funds have been lost over the years from people not realizing that they'd generated keys with an insecure sort of key generation RNG tool or something. And then funds ultimately just kind of being vulnerable in kind of an unknown way over a long period of time. Okay, so storage and access, the other two major parts of this process. I said before they go hand in hand in my book. And what I mean by that is that like access really dictates storage. So for example, if you're building an application that is needing to touch a crypto private key 60 times a minute, that obviously means that you can't have humans involved in like a cold storage recovery process. On the other hand, if you're trying to store $1 billion of crypto and you're trying to do so for like 3 years, not touch in the meantime, it probably makes sense to store your crypto in a way that is like super disconnected from the internet. You will never actually be able to have a software vulnerability lead to compromise, things like that. So they're very sort of attached in my mind. Okay, going to talk about trust assumptions in a bunch of crypto things. So MetaMask, great wallet. Tons of people use MetaMask. I think broadly speaking, people think of MetaMask as non-custodial, secure. It's running on your machine, good, right? MetaMask, great tool. It is an open source tool, which I think is a great aspect to it. It is a Chrome extension though. Chrome extensions, especially in MetaMask case, it is sort of by default a like auto upgrade. So the release engineers in consensus and in MetaMask specifically, they more or less if a release of MetaMask to most MetaMask users that will just automatically get upgraded the next time they open MetaMask. It's convenient for like release processes, but like you're putting a lot of trust in the release engineers who are actually developing MetaMask. And in my mind, that's, kind of a scary assumption. You're also putting a lot of trust in the browser itself. You're putting trust in the hardware that you're running this on, the operating system you're running it on. Like, I think the point is trust goes all the way down. Ledger is another really good example. People use Ledger. People think of Ledger as like a cold storage offering. I think arguably it kind of is, kind of isn't. Ledger's great and has been responsible for, I think, keeping a lot of the industry safe over the years. But also, Ledger uses completely closed source firmware. I don't know if people remember the kind of PR debacle from a year and a half ago or whatever. It was, I think a lot of people became aware at that time that Ledger did have the ability to push upgrades that can do things that seem like would violate the constraints or, what the device is supposed to do. In this case, they shipped a sort of product feature that let people kind of extract a seed phrase from the Ledger. My guess is that pretty much everyone who uses a Ledger just blindly upgrades the firmware anytime there is a new firmware. So you're putting a lot of trust in the Ledger development team. MPC is another thing. I think that there's kind of like unknown and underground like trust assumptions everywhere. So people love MPC. I think there's a lot of value in certain architectures of MPC. But if your MPC signing system is just kind of blindly signing any request that comes through, or blindly partially signing any request that comes through, and there's no difference in the people who control access to these different nodes and like no difference between the actual machines that are running them. Well, basically you've like reduced something that has the potential to be, distributed and trust being distributed across a bunch of people. You've now reduced it down to kind of the same set of vulnerabilities as a single machine. Trusted hardware also, tons of trust assumptions baked into that. Inherently, you're trusting the hardware. You're trusting the secure coprocessor of a piece of hardware like an HSM or TE. Okay, what questions should you be asking them? So what vectors of attack do I want to minimize when it comes to key generation, storage, and access? And I think the operative word here is like, what do I want to minimize? So when you're building an application, like what are the critical things that are important based on the access patterns and value that you're actually storing? That completely dictates like the questions or the answers to these questions. I think, like actually before I was talking about, cold storage, at Coinbase, we were working with clients that had billions of dollars of crypto. And like, obviously I wouldn't ask that someone store that in a super, super hot fashion. But if you have, if you know that you're only going to access it every, couple of years, keep it offline. So how comfortable am I in trusting a piece of software or hardware in generating, storing, and accessing keys? Also kind of, we were talking before, there's just so many places that you are inherently trusting software and so much more software that you are trusting typically that I think it's worth like breaking that apart and breaking down what's super relevant and important to your business or application. And, getting comfortable trusting that because you will trust it. Similar to hardware as well. I think then also, how do you actually verify that software or hardware is running as you expect? This is a problem that I think very, very few people consider. It's something we've thought a ton about at Turnkey. It's super hard. Machines are super opaque, and there's oftentimes so much more running on machines than you think. If you look at all the processes that are running on this computer right now, it's like hundreds of them, I'm sure. And so being able to confirm that like a particular wallet or something you have running on this machine is doing exactly what you think it's doing is very, very challenging usually. Okay, and then lastly, like what parts of cryptographic security should you build yourself? What can you bootstrap? What do you even want to build? This is a super relevant question. I was talking before a lot. It's very easy to shoot yourself in the foot when you're working on this kind of stuff. And I also think it's important that oftentimes crypto storage is like not super differentiated work. So if you're building a product, it's not like highly specific to your product, the generation and like access specifically, not super specific to your product. And so like you basically like, if you want to like focus more on building your product, focus more on your building your product, I think shill to Turnkey, like we do this very well, like get back to building your product, let us do this kind of stuff that's not super differentiated for your product specifically. So Turnkey is building verifiable key management. So we are building APIs and like primitives to do a lot of these components of key management in a very secure way, and basically just allow you to get back to like building the product that you're trying to build. We have this pretty crazy threat model where we say everything in our backend is either trusted or untrusted. So a trusted thing is something that, or it has to be trusted if it could touch user funds, it could manipulate data that could lead to a user's funds being in a more vulnerable position, anything really like that. And without fail, every single workload like that will run in a testable, trusted hardware. In order to facilitate this, we've created a custom operating system to deploy these secure enclaves. So we can, using a process called remote attestation, we can verify that the code running inside of our enclaves is basically exactly what we want it to be running and nothing else. And a little bit more of a nuanced point, but that means that like we also have kind of removed any single point of failures in terms of access from this whole setup. So there's no like engineer at Turnkey who has full control over any of these systems. It's all this quorum-based, kind of consensus-based upgrade process. And then, we augment the trust by ensuring that applications only run on what we call verifiable data, which basically means enclaves at rest are there's no like persistent storage within enclaves, and so there's always this kind of challenging moment of ingressing and egressing data between like that is persisted outside the enclaves into the enclaves. And so we've built a very rigorous pattern on ensuring that the enclaves will only act on verifiable notarized data. This turns into this like very crazy trust where we say basically every machine in Turnkey's backend other than the enclaves could be compromised and funds would not be able to be stolen. So it's a very rigorous process, and we've kind of thought about this from many different angles. Cool. Okay. So if you're curious to learn more, I'll be here for a bit. Docs.turnkey.com. We have like pretty, robust documentation. We're on GitHub at TKHQ, and I'm on Telegram and Twitter if you guys want to get in touch.
Okay, sweet. We already have questions. Thank you, Jack.
You mentioned the upgrade mechanism is based on consensus, and that's decentralized. Is that decentralized just across the team or outside of the team as well?
Yeah, it's currently just within the team. Not. I wouldn't call it decentralized, really. It's like, but it's multi-party is the critical thing. Yeah.
So is the like hardware that you guys like what kind of hardware are you deploying to, and is this like and like the enclaves, is that like pre AWS Nitro enclaves, or have you guys like what's your guys' view on Nitro enclaves?
Yeah, so we're using Nitros right now. We more generally are targeting the TPM 2.0 standard though, and so Nitro is like they started with Nitro enclaves. Now they're rolling out Nitro TPM, and they actually just released the last API we need to do that transition. So eventually we'll target Nitro TPM, and then from there, basically any machine that supports TPM 2.0. So the idea is eventually to be like totally agnostic to Amazon or any cloud environment, and be able to target all different kinds of hardware.
Hey, can you explain like the non-custodial guarantees here, and like if you guys are using some sort of like MPC sharded situation combined with something else, or like what it is?
Yeah. So I was talking about that kind of like two-part architecture. We have machines that are trusted and not run, or trusted, and all of those workloads are run inside of Nitro enclaves, and then untrusted workloads totally outside of Nitro enclaves. The untrusted machines are like, they could fully observe all the requests that come into the system and not be able to actually do anything to manipulate data, change, aspects of users' accounts, steal funds, anything like that. So the way that happens is that client side, a user uses an API key or a pass key or something like that, basically a cryptographic key pair client side. They sign the entire content of the payload, and then that is ingested and only ever actually like within the enclave will make a determination based on its understanding of the user and whether it has it associates that public key associated with the stamp that it gets to be in control and able to perform the action the user is trying to perform. And so really then it's like the user's in control via this authenticator, and that's enforced all the way down into the enclave, I guess.